Hello, we are the group formed by Antonio, Javier, Carlos, and myself, Luis, and we are going to present the project of automatizing a bottling plant with a microcontroller system. Since they were invented, microcontrollers have become fundamental in our daily lives. Without them, we would not be able to use neither phones, computers, cars, and along etc. But for industries, microcontrollers are a great advantage too, as it is a way for them to automate processes, optimize the usage of resources, and increase their productivity.
Regarding the microproject objectives, our main goal is to automate a bottling plant. In order to do that, we have needed to implement a microcontroller process. During its design, we have focalized our attention in accomplish some important characteristics. These are a high accuracy for measuring the sensor values, a way to store and show forced values. We have also tried to minimize costs, for example by using a cheaper board and filling times as much as possible. And finally, a physical simulation has been done for checking that everything works properly. Focusing now on our proposed solution, its step-by-step summary could be the next one. First of all, a conveyor belt with barrels is moved until a barrel reaches a sensor. Then, the valve is opened and the valve is filled. It takes 3 seconds. Thereafter, the conveyor belt moves again. The work comes from a tank whose level is detected and shown by means of a 7-segment display. When the 4 sensors are activated, the tank will be full and an F will be displayed. When there are 3 sensors activated, the tank will be at least at half of its capacity and an H will be shown. When we have 2 activated, it will be no less than a quarter of its volume, so a 4 will appear in the display. When we have just 1 activated, it will be nearly empty, seeing a 0. And finally, when no sensor is activated, it will be in error state, so an E should appear. If error is detected, an alarm sounds and the whole process is stopped. Last but not least, we could press an emergency button that also allows to stop the process if a problem is detected. This button is an extra functionality added to prevent risks.
The code was made as modular as possible to make it easier for other engineers to understand and edit the code. 2 extra header files were added, one to declare the function of every pin and port and another common header file, where all the libraries and headers are included. It will be added to every file. As you can see, the code has been divided into 4 modules. The external interrupt module contains the initialization of the pins that are connected to time-sensitive events, such as emergency stop button or bottle sensor. Then the interrupt handler routines are configured in the STM32IT module, meaning which actions will be taken if a timer or external interrupt events occurs. For example, if emergency stop button is pressed, shut down the whole system immediately. The start routine and input-output functions are configured in the bottler module. The activation of actuators, the sensor reading, and 7-segment display refreshing functions are included here. Finally, in the main module, only the initialization routine and sensor reading functions are going to be used, as every other task are time-sensitive, so they are declared in the interrupt handler module.
Now I will explain why is our project a good option. Our project accomplishes the specifications as well as possible, and if that weren't enough, it has different extra advantages to keep in mind. Firstly, the code has been done in a modular way. That means if it is necessary to do some addition, it provides the user an extra easiness. Additionally, due to the number of LEDs and buttons that it has, we know the state of the process in every moment. And to achieve the highest accuracy and velocity, we have used interrupts. Moreover, when the safety button is pressed, everything stops, and the alarm is turned on until the reset button is pushed. Therefore, there is a 7-segment display that shows the level of water inside the tank to make it more visual. Finally, our board is cheaper than the Discovery, which is also a good point to consider.
Summing up, we arrived to the following conclusions. This project has helped us to understand how microcontrollers can be used to automate industries. We were even able to add some extra functionalities to improve the productivity and preventing risks. Finally, the project is adaptable and reusable for other projects, thanks to the modularity. I would like to thank you in the name of the group for reaching the end of the presentation. Goodbye.